All right, welcome everybody. My name is Paul Lammertsma. I work at Google and I work on the Android TV team. Super excited to be back in Berlin. It's great to have these in-person events again. Absolutely love it. I'm here to talk a little bit about what's new in Android TV and Google TV. So with so much content available on devices today, it's no wonder that 1/3 of US households are watching over 25 hours of content on their TVs each week. And with Android TV seeing such incredible growth and momentum, we announced this year at the Consumer Electronics Show that Android TV OS now has over 110 million devices activated. So just skipping through this. And also, Android TV and Google TV are available in over 300 partners worldwide, 7 out of 10 top smart TV OEMs, and among the pay TV providers, over 170 of them are also using Android TV OS. And in this last year, Sony, TCL, Hisense, and Skyworth all announced new TVs running Google TV, which means now that the majority of TVs coming onto the market in the US are with Google TV. So, now we've also launched some great new features to make Google TV even more helpful and bring some excellent new content and some new features to our favorite form of entertainment. And I'd like to spend the rest of this session talking about some great new features, both for users but also for developers. For users, for example, we have launched profiles so everybody in their home can enjoy their own space. So in a user profile, you get personalized recommendations based on your own interests, where you can save your shows into your watch list and include movies and episodes for watching later. And users can also create their children's profiles using kids' profiles to basically access a fun collection of family-friendly content. They also have the opportunity to use parental controls to restrict what they are able to watch, what the children are able to watch, and limit the watching time. So within these profiles, you as developers can curate personalized content using the Play Next row, using the Watch Next API. So that should be hopefully somewhat familiar to you. If it's not, you can find a lot of content in the developer site and other resources that we have at Google. So if you're anything like me, maybe you lost your TV remote between the couch cushions. The virtual remote lets you control your TV through your phone and makes it easier to type usernames and passwords in applications that require you to do that on the TV. So as a developer, it's important that you allow conventional key input wherever you're prompting users for input, and don't rely just solely on a on-screen keyboard. And by the way, Gboard works absolutely fantastically on TV, so maybe you want to think about not having an on-screen keyboard at all inside your application. So the TV team is committed to bringing you helpful products and making the developer experience on Android TV OS much easier. I'd like to recap what we have brought to developers, what's new to developers in Android 12 for TV. Take a look at what's coming for TV in Android 13. And finally, let's look at some features in beta and revisit some of the conventional TV topics like media sessions and validation tools that can help you reach get the reach and the performance to get your applications up for the next generation of devices. So for Android 12, we focused on 3 key areas. The frame rate switching API, which is an API that allows you to request a very specific refresh rate from the platform. And this creates a seamless transition on supported panels. So it's great for games, obviously, that have a desired frame rate. But it's also especially good for TV shows and movies that are recorded in a fixed frame rate. Think like movie content, maybe at 24 FPS or something like that. Second, compatible TVs will begin to be supporting 4K UIs. So it's important here to think about designing your applications in a responsive manner so that they can use these higher density displays. And as always, just in general on Android, you shouldn't be making any assumptions about how what the screen dimensions are or how your application fits into a very specific screen size. And finally, accessibility continues to be a big focus for us, and this particular feature, text scaling, brings a new feature to users to allow them to adjust the size of text on their TV screen. This is, of course, a feature that has always existed inside mobile. It's coming to TV now as well. So it's important for you as developers to think about how that might affect the way that your application renders, right? It might push text off the screen or some other issues that you might not have thought about before. So it's important to basically think about supporting text scaling on all Android devices now. So let's take a little bit of a closer look into the frame rate switching API. So we added a new preference in the Google TV interface here on the left, where you can set the preferred behavior for display switching. So here we have the seamless mode selected if the panel is supported. So if your application is playing a piece of content that's being recorded at a very specific frames per second, or FPS, you can use the set frame rate API to inform Android TV about what that content frame rate was. And the platform will take care of respecting the user's preference for matching the content frame rate. So even if the panel only, for instance, supports 60 hertz, if you call this method with a set frame rate that your application prefers, panels that don't support that frame rate, it just won't do anything, right? So it will only apply that actual frame rate in an attempt to do a seamless switch on devices that are able to do that through HDMI 2.1 variable refresh rate. One other thing here, when you call set frame rate, it's best to pass the exact frame rate, so don't round it to an integer. For instance, if you have a video that's being recorded at 29.97 hertz, don't round it to 30 because those are distinct frame rates. So just provide the exact number. In that case, it will be 29.97 instead of rounding to 30. All right, so here we can see how we actually perform a seamless transition using the HDMI specification and the 2.1 variable refresh rate. So we signal to the platform that the source source frame rate is fixed, because in this case the video would be recorded at, like, say 24 frames per second. And then the system should prefer switching if the transition doesn't cause a blank screen. So when we talk about what it means to be a seamless transition, it means that the display will just switch without the user really noticing any hiccup. When it's a non-seamless transition, that usually means going through like a blank screen for a couple of seconds, so that can be somewhat disruptive to the user. For this reason, we have the option for the user to select only seamless transitions. So this is a very effective way to prevent frame stuttering by ensuring that the panel's refresh rate is in sync with the content that you're trying to render on it. Right? You have to imagine that, for instance, if you have 50 frames per second content, you're trying to play it on a 60 hertz panel, that there's going to be some frame drops and it's going to hiccup a little. It won't be very smooth. So what if all of our content is at the same fixed frame rate, right? Here in Europe, for example, a lot of original content is recorded at 50 frames per second instead of 60. So it might make more sense then to switch over to the preferred display mode when the application receives focus instead of when content is playing. Because, again, if all of your content is at 50, then you're constantly going to be switching, right? So to do so, we should first check if the switch will be seamless by inspecting the display mode's alternative refresh rates. So if the switch will be seamless, we can check if the user has specified a preference to match the content frame rate. Sorry, if it won't be seamless, we can check if the user has specified a preference to always match the frame rate. So if they've selected the second option, for instance. And then only if that is the case, so only then do we specify the preferred display mode to one that matches our content frame rate. And we do that by setting the window manager's layout parameters to the preferred display mode. So I would recommend doing this in the case that your application receives focus and all your content is in the same frame rate. All right, great. So with the frame rate switching squared away, and when you're thinking about designing your applications, like I mentioned, to be responsive, for that 4K UI, not making any assumptions about screen sizes, taking care to respect the user's text scaling preferences, great. You're on your way to developing a great Android 12 TV application. But let's not also forget that there's also the launch of profiles in Google TV, where you can curate age-appropriate content on individual user spaces, whether it's for children or for adults. So think about how you want to integrate with the Watch Next API to give users their continue watching and recommended content there separate from the other profiles. So if you haven't already, now is a great time to think about evaluating your TV for Android 12 compatibility. And it's available already with or without Google TV on both the emulator as well as on the ADT3 developer device. All right, so moving on from Android 12. Now in Android 13, we're bringing even more helpful experiences and tools to allow you to build native experiences across a variety of living room configurations. And we focused basically in 3 key areas, I would say. We have the audio routing, the anticipatory audio routing. These 2, I would say, are in the category of accessibility. And we've also done some performance enhancements, and most of them don't really affect developers so much, but there's one that I would like to call out here. So let's just dive straight into those. So anticipatory audio routing. So improved APIs in the audio manager now let you anticipate the audio route. And the way that this works is you can use the new audio manager get direct playback support to understand more precisely which playback mode is available on the currently active route with a particular set of audio format and audio attributes. So those are a lot of words. Let's take a little look at some snippet. What you can do is you can check if a specific combination of audio format and audio attributes can be offloaded or passed through for direct playback with the device. Now, when I say direct playback, what I mean is the audio is passed through straight to the audio playback mechanism, and it's not being transcoded by the platform in any way. So suppose that you have an audio format and attributes in, like, say, Dolby 5.1 audio. If the device would be coming in between, it was not direct playback supported, it might be transcoding it, for instance, to stereo PCM, and maybe that's not the best format for your user. I mean, it's first of all using bandwidth, and second of all, it might not be the dedicated stereo experience that you're trying to give to your user. So how can you then know this device actually is going to be supporting 5.1 audio? So in this example, suppose we have that 5.1 Dolby Digital Plus. If you'd like to know if direct playback is supported, you can query the get direct playback support. And you might want to fall back to a different format, like PCM, if it's returning direct playback not supported. So if we don't perform this check, the audio might be doing that transcoding, like it could be falling back to PCM. It might be doing some transcoding internally because the decoder is not available, which is just a waste of bandwidth. It's not optimized for your experience, for your users. So that would be what the situation that you want to avoid. So there's a more robust approach we can take for this if you have different audio routes available to you by evaluating the best audio profile support for that direct playback. And we can query the profiles before creating an audio track and to see which ones would be directly rendered. That would exclude any profiles that are unsupported or would be, for instance, like I mentioned, transcoded. So let's take a look. Let's build a little snippet to see this in action. First, we will define a method that we'll call best audio format to select the best audio format for the active audio path. And we'll take audio attributes as a parameter, and we expect it to return the best format. Now, we'll start by handling the default case to simply return audio format in PCM. I didn't implement it here because it wouldn't fit on the slide, but it would be that last line. And then we can use get direct profiles for attributes to query which profiles would be supported. That's on the very top of the slide there. So in this manner, we can check if the active audio path supports Dolby Digital Plus, and we can then fall back to Dolby Digital if it doesn't, and then we can then fall back all the way to that last line that I had there to fall back to PCM as the default. All right. So once we know that direct rendering of one of the audio profiles is supported, we can perform a very similar trick to do the same thing for the channel mask and the sample bitrate. And then once we have identified all of these parts, only then do we actually continue with creating the audio track. So I mentioned that last bit that we only do the creation of the audio track as the last step because that's great for performance. If you are constructing audio tracks with the sole purpose of evaluating whether it's supported, that's a lot of overhead that you're creating, and it's not good for performance. So doing this approach by first evaluating which profiles would be supported, and then only in the very last step, actually creating your audio track, that's really the recommended approach. All right, cool. Moving on. Next, we have the system-wide accessibility preference, allowing users to enable audio descriptions across apps. So don't confuse this, by the way, with captions. Audio descriptions is more a detailed verbal description of like visual elements that are in the content that you're watching. So as an example, do you remember in like Forrest Gump, you had that opening scene where there's this feather drifting in the air, floating around, past the rooftops and everything? So what I just did, that's an audio description, all right? And it offers like a dedicated audio track. Typically in something like in some content piece, you might actually have a dedicated audio track for the visually impaired that describes sort of key visual elements that is going on. So your app can leverage the new API in the Accessibility Manager to comply with the user's accessibility preference for enabling audio descriptions. And to do this from the Accessibility Manager, you can easily just obtain the user preference. So you can just simply query from the Accessibility Manager whether the setting is enabled or not. Easy enough, right? Wherever your media player is being initialized, just check if the accessibility setting has been enabled, and if so, enable the respective audio track inside your stream. So this is pretty simple, but it's also best to register a listener in the case that a user enables this enables this setting while the content is playing. The reason for that is you should remember that there are accessibility services that might be toggling these settings on or off without the user actually leaving your app. So if you're only doing it when your player is being created, if the user somehow manages through an accessibility tool, like they have like clicker devices, for instance, then your application might not be responding on the fly. All right, moving on to the next one here. In 13, we also see different keyboard layouts. This also applies for TV. So as a game developer, you might be thinking about how you can use the Keyboard Layouts API to reference keys by their physical location. I'm a bit of a gamer myself, so if you're using the WASD keys, it makes sense for a QWERTY keyboard, but what if you don't have a QWERTY keyboard? Are you actually trying to map against the WASD keys because they might look different on a different keyboard? So let's take a look at a little snippet here. When input devices are changed, you could, for instance, remap directional keys from a non-QWERTY keyboard. So from the layout of a non-QWERTY keyboard to a physical keyboard. The way that this works is we can identify which keys correspond with a conventional WASD layout. So I'm still mapping against the WASD keys, but I'm returning a different key code, for instance, if this is like an AZERTY or an AZERTS keyboard. And the way that we do this is the very appropriately named method, get key code for key location. And this is how I'm mapping the up, down, left, right. All right. Okay, and then about the performance. So we've brought this new thing, which is HDMI state changes, which allows playback applications to be notified when the Android TV device is saving power. So, for instance, if the Android TV device is powering down, it can send a signal to your application that is trying to save power. And the way that that works is it actually signals a pause command through media sessions. So if you have integrated with media sessions accurately and you're handling lifecycle events accurately as well, you should be squared away. But I'll touch on some validation tools of how we can make sure in just a minute. But this is actually a good moment for a little intermezzo because there's an opportunity to talk about media sessions in general. Media sessions are a little bit tricky because first of all, we should be thinking about different ways in which users are interacting with content in your app in the first place. What does it exactly mean, when I say the platform signals that media should be paused? So if we put the HDMI state changes aside for a minute, we can look at some different ways which users control media. For instance, the Android platform itself offers a few services through which media can be controlled outside your app. For instance, it might be media controls on Android, like on a phone. It might be through the quick settings on phone and tablets. It might be through dedicated media controls in the overlay, for instance, in a watch in Wear OS. From peripherals, you might also have TVs or Chromebooks with a keyboard attached that has media controls. You might be using, with a dongle attached to HDMI, maybe sending signals through HDMI to issue pause, not just from the HDMI state that I was talking about just a minute ago, but also from conventional TV remote controls that are sending a signal from your TV, for instance, to a dongle running Android TV. And then, of course, there are other ways which make sense, right? Accessories like wired headphones or Bluetooth speakers or earbuds. And we also have, of course, the Google Assistant. Users might be issuing voice commands through the Assistant to control media on the TV. So there's a lot of different ways in which content is being controlled. And the new Jetpack Media 3 library makes it really easy to connect your player with a media session. And by connecting the player to the media session, it also allows Android TV to understand how media is being played inside your app and support all of those cases that I just discussed. So here's a snippet for building a player with a media session using the Media 3 API. And notice in this new API how it basically just constructs a media session from the activity context and instance of ExoPlayer. So I've created a very basic instance of my ExoPlayer, and I've provided that reference into my media session builder. And if you're familiar with Media 1 or Media 2, take note here that you no longer need the media session connector extension for ExoPlayer to make this connection work. This is literally all you need. So once you have put this together, your media session that is already connected, many of the base cases for handling various media actions like pause and play and skip to next already work out of the box because you probably provided enough context to ExoPlayer itself to understand what your media queue looks like and that the content can, for instance, be paused. You can, of course, expand on this, and I implore you to take a look at the Media 3 documentation to understand exactly how you can implement custom actions, that sort of thing. Equally important is, of course, taking care to clean everything up. So with a reference to our media session, make sure to also release it wherever you're releasing your ExoPlayer as well. And so long as your media session is not released, it's very important to bear this in mind, it will remain available for the controller to connect to it. And that might cause some weird issues in your app where you exit out of the app, the media session still exists, and a user might actually invoke, Google Assistant and attempt to resume playback. So what happens inside your app when that happens? Maybe it's stealing focus from another app that the user has switched over to. So be careful with that. All right, great. On the topic of media sessions, we've updated a couple of our validation tools to support Android TV. For one, the Media Controller Test app allows you to test the intricacies of your media playback on Android, and it also, of course, helps you verify your media session implementation. So this particular framework offers basically one-click tests to run, to basically ensure that your media app is responding correctly to any playback requests. But this is not just for TV, it's also for mobile. So it's a broad set of validation tools, both for mobile and TV. The Media Session Validator is a tool that is much more tailored towards TV. So it offers a way to verify your media session integration, but it also verifies any prerequisites for supporting Cast Connect. So I encourage you to try them both. It's very helpful for automated testing as well, to make sure that your media sessions don't have any regressions. All right, cool. While we're doing our intermezzo, let's just stick on this topic. One other thing that I wanted to talk about is reminding you of handling ambient mode. And what do I mean by ambient mode? Well, when you are playing user-initiated video playback, you must prevent the device from going into ambient mode. So if you're playing, for instance, a movie or a TV show, you have to make sure that the TV doesn't switch off. I mean, it makes sense, right? But you'd be surprised how many people they test the app, they see that everything works good for like a minute or two, it's all fine, it goes into production, and then in the third minute, the TV actually switches off. So it's very straightforward. all you need to do is add a window flag to keep the screen on. And you can either do this directly on the window manager, or you can set an XML attribute if you're using views, so that basically the screen remains on. If you're using the first option to set a flag on the window, make sure they also remove it afterwards, because equally important is when there is no user-initiated video playback, you must not be preventing the device from going into ambient mode. So yeah, basically, as I said, if you've previously added the flag, just be sure to clear it on the window again. All right, with that out of the way, let's go back to what's new in TV. So in line with the Android Core release schedule, Android 13 Beta 1 emulator for TV is available already, and so is the image for the ADT3 developer device. So you can use these already. Also take a look at the release notes to catch up on any kind of more detailed features that are maybe more specific to you and didn't really fit into what I wanted to discuss today. That's basically for Android 13. I want to talk briefly about some features that are in beta. This is the final section. There are some features around multitasking that are currently only in beta. And what we have been seeing is how consumers increasingly use their TV not just for watching media content, which is why we're improving the multitasking from, basically being able to do different kinds of things from the comfort of your couch, like, having video calls, catching up with your family. I know I do. My family lives in a foreign country. Or being able to monitor cameras throughout your smart home. So this is all made possible with the updated picture-in-picture API, and this is currently in beta, in Android 13 Beta 1. Now, this API is the same picture-in-picture API that we have for mobile, which supports actions and automatic entering and exiting. So that would be like also the on picture-in-picture mode changed callback in your activity or fragment. But for TV, we can make use of this larger screen to support a new expanded picture-in-picture mode, which looks like this. And to do this, let's take a little look at a snippet of code here. We first need to check if the device supports this feature by inspecting the respective package manager flag. So let me see, I think that's the next snippet. Yeah, exactly. So if the system has the feature expanded picture-in-picture, we know that we can use this new mode, and then just like the set aspect ratio, the set expanded aspect ratio now allows you to render the contents of your activity in this expanded mode. And what I've done here is I've defined the aspect ratio so that it accommodates all the participants of this hypothetical video call. Yeah, that's the feature we're looking for, and this is the aspect ratio. All right. So when in expanded mode, picture-in-picture defaults to a docked layout, and that's to prevent it from covering up any critical content of the underlying app. So suppose you're watching some soccer game or football game, however you want to call it. You don't want the picture-in-picture overlay to appear on top of that in this case. So this underlying app has some control over this as well. It can choose to opt out of this docked mode if it makes sense. For instance, maybe when you're browsing content. I gave that example a little bit earlier. And let's also take a look at a couple of ways with the underlying app, and I've shown that in yellow here, by the way, how it can affect the way that the picture-in-picture of another app, which is the blue one, can be controlled. So we want to make sure that apps make optimal use of the screen, even in this docked mode, which is why it's important that this yellow app, this underlying app, is resizable. Because if it's not, and you're not targeting the Tiramisu SDK preview, and you're not declaring your application as resizable, you'll see how the application is then scaled down in this topmost image, which is also resulting in letterboxing. So apps that target the Tiramisu SDK preview can then resize to fill this space, and you don't get that. You can avoid this letterboxing without being scaled down. So you can render at the actual resolution, and you can make use of the actual space available to you. Of course, important to point out here, once again, the aspect ratio of your screen is then no longer 16 by 9. It will be something else. So again, think about having responsive layouts. All right. Also worth calling out here that the default value of resizable is actually true, but just calling out that maybe you're being specific about resizing to false. And just to call out here, this is not final. This is for beta feedback in 13 beta 1 only. So yeah, just bear that in mind. Okay, for cases where applications prefer to remain full screen with a picture-in-picture overlay, you as an underlying app can specify the set should dock big overlays, it's a mouthful, to false. So while we definitely recommend making your applications resizable, permitting this window overlay is perfect for making optimal use of the screen while users are browsing content. So you see how basically in this case the picture-in-picture dock is appearing on top of browsable content. Now, if you're concerned that your full screen app may have important content that it would be obscured by a picture-in-picture overlay, you can make use of one of 3 of the new Keep Clear APIs. This API is designed to be able to keep relatively small regions of the screen free of any kind of overlay, including the picture-in-picture overlay. So here you see, for instance, that as the user brings focus into that last element on the screen, that the picture-in-picture momentarily stashes in the corner of the screen. So on a view, you can either specify a region of a view or the whole bounds of it to the Keep Clear area. And the system will then try not to place any floating windows around them. So similarly, you can also do this through the XML attribute for setting the entire view to be kept clear. And it's worth pointing out here that attributes that receive focus automatically respect the Keep Clear attribute. So you don't have to, in this example that I gave here, when it receives focus, this will already happen by default. A better example might be maybe some text that you want to display about, copyright or something about the content of your video. You want to keep that clear from any overlays. All right. So just a reminder, these APIs are in beta. They're subject to change. So it's for feedback only, and I ask you to provide some beta feedback if you're using it with the Android TV OS team. This is a group alias to the team. We'd be super eager to hear your experiences, in particular about understanding the use cases that you're aiming to solve for with using this new picture-in-picture mode on TV. Or also just in other ways that you're thinking about multitasking on TVs. All right, brings me to my final section of this presentation. I'd like to take a look at some of the areas in which we can just build, in general, just great TV apps. So app bundles, as a reminder, is a great way to reduce the size of your app and retain users on more memory-constrained devices. There's some obvious benefits to doing this. You have a faster app download. The application size, of course, is smaller, so it uses less storage space. You have faster releases because you don't need to be thinking about building your app with multiple multi-APK support. And you can also think about having dynamic feature modules, of course. All the benefits, of course, you have for mobile as well. And then voice control as well, allowing the user to control audio and video playback through media sessions. Just as a reminder, the different ways in which voice commands might be issued and supporting those. Also thinking about supporting custom actions, for instance, turning on subtitles. And then also Cast Connect. Cast Connect is a great way to enable casting directly into your native TV app. So not just casting to a TV receiver, like a web receiver. Cast Connect, what it actually unlocks is it deep links into your app where users can continue to engage with content using the remote control. And for this piece, we actually have a great code lab. You can explore that in more detail from the developer side. Just a reminder about app quality. We have quality requirements on the developer site that give a very clear outline of the different requirements that we have for publishing an app for Android TV. It's basically an overview of some explicit testing steps that we would recommend that you follow through with to sort of align yourself and be in the best shape for actually submitting to Google Play. And it includes a couple of the topics that I discussed already, including media session. And that checklist is an itemized list of recommendations to get aligned with the app quality guidelines. So this includes details about requirements for general form factor support, the media session, the ambient mode. It includes play next, and also some specific recommendations for games on TV. So also check out our developer YouTube channel. Contains a lot of videos with more details on these topics. Includes TV app engagement topics like Watch Next API. Media sessions is always a ongoing topic. Account linking. There's billing integrations. We have content for best practices in accessibility by Ian. That's a great video. Some other great topics for TV as well. So yeah, thanks again for your ongoing support for Android TV OS. It's great to see the great content that we have on the large screen in the living room. If you have any questions about this, please visit our booth. We're right just outside here. Feel free to reach out to me afterwards. And again, if you are testing the beta features, please give us some feedback using the alias so we can build the right solution for developers just like yourself. So thanks for listening. Thanks.